Identify the chemical nature of the reactants. HC2H3O2, acetic acid, is a weak acid. Unlike strong acids, weak acids only partially ionize in aqueous solution and exist primarily as intact, neutral molecules in water. Therefore, in net ionic equations, they must be represented in their intact molecular form rather than as dissociated ions. NaOH, sodium hydroxide, is a strong base. Strong bases are strong electrolytes that dissociate completely into free ions in aqueous solution. NaOH gives Na to the power plus OH to the power negative. Formulate the complete molecular equation. When acetic acid is titrated with sodium hydroxide, a neutralization reaction occurs to produce liquid water and the soluble salt sodium acetate. HC2H3O2 plus NaOH gives H2O plus NaC2H3O2. Write the complete ionic equation. Express all strong electrolytes, the strong base NaOH and the highly soluble salt NaC2H3O2 as dissociated ions, while keeping the weak acid and liquid water as molecules. HC2H3O2 plus Na to the power plus OH to the power negative gives H2O plus Na to the power plus C2H3O2 to the power negative. Identify and cancel spectator ions. Spectator ions are ions that appear in the exact same state on both the reactant and product sides of the chemical equation. In this reaction, the sodium ion, Na to the power plus, does not participate in the chemical change and remains a spectator. Subtracting Na to the power plus from both sides leaves the net ionic equation. HC2H3O2 plus OH to the power negative gives C2H3O2 to the power negative plus H2O. Conclude. This equation correctly represents the actual reacting species, intact weak acid molecules and free hydroxide ions, and the species produced, acetate ions and water. This matches option C. The correct answer is option C. HC2H3O2 plus OH minus gives C2H3O2 minus plus H2O.